This is Levi
Adrian.
and we are doing Lab 2, which is Common HMNR Splitting Patterns. And we're looking at the last question here, specifically that we did here. And it says degrees of unsaturation, and to find that we use the formula, or the molecular formula, and put it into the unsaturation formula, which it was C2 plus 2, yeah, you know what it is. Then we plugged it in with the carbon here and the hydrogen here and the halogen here. And once you calculate it out, you get 0, so there is 0 degrees of unsaturation. Molecular weight from the formula, we knew there's 2 C's, so and they each weigh 12, so it was 2 times 12 equals 24. And then the hydrogens, there's 4 of them, they each weigh 1, so there's 4. And the chlorines, there's 2 of them, and they each weigh 35, and so that's 70. You add them up, and that the molecular weight is 98. Distinctive IR peaks. So we need to look at the IR spectrum. And that's this guy here. This right here is our 1500, so everything over here is fingerprints, so we're not going to look at that. And then just kind of looking at everything else, this is just our normal organic peaks, and that's in everything organic, so we're going to ignore that. Doesn't look like there's any single bonds, there's no carbonyls, doesn't look like there's a distinctive double bond, there's no distinctive triple bonds, doesn't look like there's any kind of alcohol or anything over here. So it looks like they're all single bonds. Well, sorry, when I said no single bonds, the single bonds are over here. So it looks like it's all single bonds with nothing really special going on here. So distinctive IR peaks would be none. NMR data. So if we look at our NMR chart here, obviously there is just one single bar here, and it falls in at about 3.7, but I think it even, yep, specifically gets to that at 3.7. So we have one at 3.7. And the weird thing about that is we have 4 hydrogens and 2 chlorines, so it's kind of weird that there's only one peak. But the thing about that is that it's probably going to have to be symmetric, because that's the only way that 4 hydrogens can go on 2 carbons and only have one IR peak, or not IR peak, sorry, NMR peak. So it would end up looking like Cl bonded to CH2 bonded to CH2 bonded to Cl. That's our, we got 4 on this carbon, 4 on this carbon. Our Cl's are happy, and right here is our symmetry. So these two right here will actually have the same peak. And that's how we did the last question.